Now I'll show you on how to use a curve tracer. So before we start using a curve tracer, let us get familiarized with what is curve tracer. Okay, the curve tracer that we have is a HAMAC HM6042 curve tracer. So when you switch on the curve tracer, the first thing that you're going to get is welcoming things, and then you have to set the device that you want to measure. So this is a device adapter, so you can put a two device in one device adapter. So you can choose either FET base or a silicon based transistor. So DUT is the device under test, which is put in this device adapter. Alright, so what next that we have? This is a maximum current that will flow through a device. This is the maximum voltage, and this is the power of maximum power that will go through the device. So in this case, you will start with a low value. I'll show you on how we can play around with this value to measure a diode. Okay, so you have to set this thing first. Alright, I'll give you one example. So this is a silicon based diode, so I'll put this thing under NPN or PNP, doesn't matter, it will be the same. So if I use NPN, means that the current will flow through C to E, so that's the diode that we want to measure. And then I'll put this thing on the NPN. So this is a bipolar input, this is FET based input, N channel, or bipolar NPN, so bipolar NPN. So I know that this is a signal diode 1N914. I just want to measure whether the device is in good condition. So what I knew about the diode is the current is small, so I can put the power quite small. I just want to know whether the diode is in good working condition. So everything being set, so I put it into device under test 2. So now what I need to do is to measure what is the V across the diode and what is the current across the diode. So this is the V across the diode. So this will tell me what is the knee voltage of the diode. So we can see here, this is 0.53 volt. The diode is still off. So if I increase this thing slowly, the diode is about to turn on, 0.63 volt. So now the diode is on, meaning that whatever the voltage of this, the diode will conduct. So this will give me 0.72 volt where the diode will conduct, and I can measure the current. So this is the current that flow through the diode, which is 0.7 milliamp. What I can do next is I can increase the diode, the current through the diode. Still, so this is 0.9 milliamp. You can still see this is 40 milliamp, meaning that I'm increasing the power. I can increase the voltage slightly, but it still be the same because the diode already turned on. What I'm doing here is that I'm giving more current flow through the diode, so we can see the behavior of the diode. Can increase the voltage. Now it gives you a warning because you don't know what to do. So now this is, if I measure the voltage here, so this is 0.78 already turned on. Still will do the same thing. So it's already on, off, on. So now 0.79 volt across the diode. The current that flow through here is 10 milliamps. So now I'm stretching the diode. Okay, next I'll show you on how we can measure a Zener diode. So this, I've already put a Zener diode in my device under test 2. So this is a Zener diode. So if I play around with this, I can see that this is the knee voltage, but then I cannot see the span of the Zener diode. So I need to increase this thing, and then you can see that this thing will take some time. This is the maximum. So now, because I'm putting too high voltage across the Zener, this device will turn off automatically. So what I need to do is to reduce the voltage slightly, and then the current slightly will go back with this device. So this is the current that flow through the Zener diode. What I need to do is to increase the, you have to be very gentle with the switch, very sensitive. Okay, so now we start turning on the Zener. So now the Zener is already on. So you can see that the Zener is on. Now we'll just want to see when the Zener will start to level off. So I need to increase the current slightly, and then the voltage, and then we'll see. So if I increase the power, and then what I can do next is to increase the span. Increase the span. So now if I move the cursor, then you can see that this is a 6.3 Zener diode. 6.3. So you can see now, if I don't have enough power, there will be less current or voltage that go through the Zener diode. So I'm putting in 4 watts. So this is the amount of power, voltage and current that will go through the device. So the current that flow through my Zener is 73.6 milliamp. So from there you can find what is your Zener resistance and so on. Okay.